Okay. Hello, everyone. You have a great day today. Guess we can start. If people come a bit later, it's not a problem. Everything is recorded, so you'll be able to see the entire webinar later if you want. Okay, so today's topic is harnessing agentic AI, RAG, n8n, and knowledge graphs. It's all about medical data workflows, but if in case you are not in healthcare, everything can be also related to any area here. Probably the most thing which differentiates healthcare is the importance of data precision here. But as I said, it's also could be related to any other field. So shortly about me, I'm a CTO of Agiliway. Agiliway is a software development company. We are 10 years in the market, lots of projects successfully completed and currently ongoing. We are located in different areas. Our headquarters is in Austin, Texas, where I'm based on, and our development centers are in Eastern Europe, in Ukraine and Poland. We have a bit more than 200 people and growing. We have a lot of certifications partnership, including Microsoft partnership, AWS, Amazon. We are also ISO certified company, both 9001 and 27009, 001 security certified company. We are GDPR compliant. We work with also HIPAA compliance, aware of that. So let's get to the topic. So let's just talk about AI in general and what it is and what basically it is. So this is probably all heard about things like AI, ChatGPT, and talking with this, you probably also heard about a term called LLM, which stands for large language models. So this is a basis of all the AI that you are currently working with, and I'm pretty sure everyone present here tried things like ChatGPT or Claude or Google Gemini or something like that. And basis on that, well, this is large language models, and this is let's say it's like a system and a database and a knowledge base of trained data based on lots of open public information that currently are in internet, like books, articles, forums, and based on everything which was collected, and those systems try to then answer all your questions that you have based on all this information that it has. So let's say if the system read a really big science fiction book and you ask any questions about, let's try to write, let's create some short novel, a science fiction novel about this and that, based on all the trained information on science fiction novels that it was trained on, it can generate you combine like some new ideas and something like that. So basically, it predicts what you want. It's not really smart. I need to say it's just things that's trained on everything it could read publicly and try to answer based on that. So what is So large language models consist of three words. First, large. Large is because it's trained on really, really big amount of data. It's like petabytes of data, and the training itself can take up to a couple of months of collecting and training based on all the information it can receive. Language, it's why the language stand here is because the primary job of those tools are actually respond to your native language that you write on. It can be English or anything, but basically you send a question or inquiry in your native language, and this model responds you also in your native language or in the language you ask this tool to respond. And a model is just because it's basically a system, a database or a file which you basically works as a collected data based on which you receive a response. So you can like you can do this and you can create this LM yourself, of course. Any company can. However, the problem with that is currently, if you want your LLM, your personal LLM, to be really performant, responsive, it costs a lot. As for example, latest ChatGPT, GPT-5, only one training cost was about from $1.5 to $2.5 billion. And not only that, it also requires a lot of energy consumption. And this one training for GPT-5, for instance, was required like so much power to as the same as every consumption of 320 US homes in a year. And not only that, so we expect that all further models, let's say in future ChatGPT, GPT-6 will cost even more. And the problem is not only it's money cost and energy cost, it also requires a lot of water and other things. So you can do it yourself. It just becomes more and more expensive, and only big companies currently can afford creating those models. So the best way for now is just to use what's currently there on the market. Besides language, those tools can also generate things like images, audio, videos, 3D models, like currently anything like that. So this is, as you see on this slide, you can see just a simple. I asked it, Google Gemini to generate like image representation of what is LLM. And if you take a look closely, you can see that this generated image has mistakes and typo there, and still even today those just a reminder that still even today those tools are not perfect. So we just need to keep that in mind. So LLMs are not magic. Like this is just a tool which trained on a lot of data, and some LLMs are smaller, some also bigger. The less data it trained on, the less performant it is, less precise response you will receive. You need to keep that in mind when you're working with and choosing LLMs that you want to work with. It's just a software which is trained for a long term on a lot of data, which trained on only public information, and it can respond only to what the things it was trained on. So if you, for instance, want to receive information based on your company's private data, and LLMs unfortunately cannot just simply do that, and you need to use specific techniques, which we'll talk about later, how to do that. So there's the fun things I watched on one of the conference, just pretty accurate about current state of LLMs and ChatGPT or any other right now. So if you compare ChatGPT to a parrot, it also actually runs random sentences from random people and random topics. It talks like a person, but it's not really a person. It just repeats things it was heard before or read before. It tries to do its best to please you with its response, but it's not always. It can have mistakes, and those tools can say with confidence about some specific topics, but in reality, those answers can be complete false, and you just need to take that into account, especially if you are working with healthcare data where it can be critical. And the precision, so we will talk a bit later in this webinar about ways how to make so that all your LLM tools or your GPTs respond with actually basically 100 precision if you make everything right. Okay, so we talked about LLMs. You work with ChatGPT or things like that. You ask questions, it responds, and it's like works in a passive way. So you ask, you receive response. And now I want to talk a bit more about agentic AI and what it is. So it's just a step forward from LLMs and just simple chat. Agentic AI is basically a thing which not only works reactively but proactively. So let's say you can assign an AI agent a task, and it can be smart enough and trained to be smart enough to not only perform a response to request, but also use specific tools or call another agents or call different types of LLMs depending on what is trained on. So let's say you want to, as an example, in healthcare, let's say there is a clinic, and when a patient wants to call the clinic, and the agent can answer the call, it can listen to what a patient can say, and for instance, if the new patient, it can redirect request to the, like, let's say, registration agent, which can register a user to a clinic, get all the data, check with other agents about, like, let's say, if the user is new or actually it needs to be registered, and then it can go back to agent, which can, let's say, scheduler agent, which can help you patient in a fully automatic way to schedule an appointment. Or if the agent understands that the topic is not about appointment but actually about prescription renewal, this agent can redirect request to a prescription agent, which can actually call, understand which pharmacy is this patient is assigned to, and automatically get a request to a pharmacy to renew the prescription. And then that agent can automatically, let's say, send an email or SMS with some confirmations to the user, and do many sophisticated things depending on what we want those agents to do. So not just respond, but also practically do some tasks, call other things until the basically task is done. So in continuation to what I say, it can work autonomically. It can work towards some specific goal. It can divide a task into multiple steps and call different other agents or tools or APIs to actually fulfill a task completely. Yeah, as I said, there are maybe multiple examples about what it can do. Another example can be some hardware device connected to a user, let's say, to check a glucose level and to send those levels to through API to this agent, and agent can decide if any measures need to be taken and any deviations are on, or the doctor needs to be called if anything happens, or 911 needs to be called if actually there is some critical deviations happening in the glucose level and other things. So this is just a visual representation of how agents can work. So let's say, for example, you can develop a requisition agent which operates and calls different types of other agents, and those other agents basically do their work or call another APIs or tools or communicate with each other, gets response until your necessary your task is actually implemented. Okay, so before I talked about like things that those LLMs are not, and those AI tools are not perfect, they are not magic, and they can make mistakes. Mistakes are done because even though the most modern LLM tools are trained on lots of data and they're so expensive, it's still new data appears every day. Some of the data becomes obsolete and appears not correct. But let's say, for example, the latest ChatGPT, let's say, for example, the latest LLM model was trained based on the slice of data based on April 2025. But there is new scientific researches happened in September 2025, which proved that some of the previous scientific research were wrong. But the latest LLM models was trained based on those public researches. And now when you want to check some data specific to those research, you will receive still a wrong result because the latest LLM model doesn't know. Things were changed since that. And this happens all the time. And it's just one example. Another example is just a lot of some of the things related to specific topics in internet were completely opposite to each other, and LLM trained on both of those let's say articles, which are completely opposite to each other. And when you want to ask questions related to a specific topic, LLM can, in one case, give you a result from one article, and another case from another article, and one of them is completely wrong, and you don't know which one. And this can lead to issues later. And another thing is still, even if the latest LLM model was trained on, let's say, April 2025, still not enough information. Everything is still, it still couldn't cover the entire internet information. So it's still limited in a way. It cannot be trained at everything available on the internet. It's too much. And the bigger thing here is biggest issue. So, okay, that's all great, but how do I use it in my company, my healthcare institution? How do I use like my internal data there? So I want LLM to an AI to respond based like based on both public available information and also based on internal information which is not publicly available, only available to my institution, to my rules, to my specific documents. And here comes a concept of grounding, which actually refers to anchoring AI responses to verifiable real-world information. So you want to ask specific questions to LLM, and you want to make sure that the response is always correct. So this is basically grounding. So, and in order to achieve this grounding, there are a couple of techniques that are available right now. So one of the techniques is which is most popular, and probably you heard about it already. It's called RAG. It stands for Retrieval-Augmented Generation. And basically, what it does is it just adds the existing to existing LLM your information about your true information about that you want LLM to respond. So let's say you have your internal documents, you have your internal researchers, which are only available to you and your institution. You can when you can add this information to the LLM, and when user asks on your employees or your patient or anyone asked a question specifically which is related to your organization, to your researchers, LLM will combine publicly available information with your internal information, and will return the correct data based on combination of publicly available information and your. And besides that, you can like this response will return the truthful information because it will be checked by your internal documents. So technically about how it's done really shortly. So in general, how LLM works, they convert all the words, all the sentences in the vector, is actually numerical representation called vectors. And when you add your internal information, it's also converted to vectors similar to that. And when it's combined, there are like programmatical techniques which those LLM try to find semantic similarities between public information and your internal information, and will then return the correct response as you need it. Okay, so why is this important? So it's important, especially in healthcare, because like let's say, for instance, other areas like marketing, sales, like you need to have a precise information. It's really important. But in healthcare, usually it's not only important, but it's critical. So if you have an agent which tries to understand some symptoms and provide diagnosis based on that, if it's only if it's not like completely accurate, it can lead to a lot of problems and actually critical problems with health or for patients or for other things. Okay, so RAG and vector embeddings can usually increase precision of responses up to like 99.9%. The problem with that is in healthcare, this can be not enough. So you want to have precision of responses up to 100%. And in this case, we need to go a bit further and talk about things like called knowledge graphs. So knowledge graphs is a database, basically a vector database, which, sorry, it's a graph database which represents entities and relations between them in a fully truthful manner. And there are counting techniques which allow those LLMs to look into this graph database and sees information in it. And when it responds, it always checks information on this graph database. And only after it checks that that response is basically in everything is in accordance to what is currently in this graph database. In this case, only it returns a response. And since we make sure that this graph database is 100% correct, we currently can make sure that the responses of your LLMs can also be basically 100% correct. Let me show you an example of really simple slice of a graph database about, let's say, a patient called Robert, and all the connections and all the things related to this, to this person. So we can see that this Robert has a condition of type 2 diabetes, and he was prescribed to aspirin, and he was prescribed to heparin, and there is a connection to his vitals and other things. And so basically how it works. So when we can ask any questions. Let's say if Robert calls the clinic and wants to let's say renew his prescription to specific medications, this call can be directed to the AI agent, which can take a look into his prescription history, and the AI agent can be smart enough to understand if these prescriptions can be renewed automatically or not, and this AI tool can take a look in the graph database and take a look and see all these connections and be smart enough to understand if let's say the prescriptions cannot be longer renewed because it can lead to another health issues. And in this case, if AI agent understands that, okay, the prescriptions cannot be renewed, there can be multiple ways to proceed further. They can be declined and asked to call a doctor, or the agent can call a doctor automatically or give a request to a doctor in some specific HR system, and to manually proceed with those prescription requests. Probably a doctor can call back and prescribe something else, or just call to a visit and discuss what can be doing, other things. This all can be done because there will be all this database and all this history can be stored in such graph database, and AI, we can make sure that this AI agent is completely in accordance to all this your internal data that you have. This is just a slice for one patient, but in reality, the graph database can be like a huge. It can have a lot, like millions or billions of nodes and relations with that. It's just a really zoomed out, like a real world version of real world example of some graph database. Okay, so one more important topic is probably you all know about is HIPAA compliance, and all of those LLM tools are public, and you cannot share your patient information unless there is explicit consent from this patient to share his information publicly or externally to some specific topic, specific LLMs. So if you implement your AI solution, your really short version is not to use publicly available LLMs like ChatGPT, Google Gemini, Claude, as is. So either you sign a BAA agreement with them, or there are ways. Either you can use the local LLMs, which can be installed on your private web servers, or you can use the cloud options like AWS Bedrock, Azure OpenAI, or Google Vertex, which all have HIPAA-compliant versions, signed BAA agreements, and you can safely work with those tools. So now, probably from all of this is a least important things to see. Is just to show you how this all can be put together. And there are many ways of doing that. You can implement all of those workflows completely programmatically, or there are visual tools which can work like in integration tools, and so that you visually can see how your agents work together, how they communicate, what they call, and so just really visual example about how we can use tools like called n8n, which is a visual tool which you can simply connect different types of nodes and they see how they can work together. This tool can be installed locally on your local machine, local servers, or it can be used as a cloud version. And basically, it's just a representation of similar examples that I talked before about patient call the clinic to schedule an appointment or request a prescription renewal. And there are tools like just start everything from recall, and there are AI tools that understand what to do, and they can direct users to existing patients or a new patient, and proceed further to the end to either register or schedule an appointment, or and then provide a feedback and make a follow-up call or send an SMS to the user to make sure the patient gets everything what he wanted. And that's it. Do you have any questions? Okay. I don't see any questions so far. So if you have any questions later, please feel free to send us an email or send a message in chat when it's still going, and I'll be happy to respond afterwards. Thank you so much.